Hello students, welcome to the new course in chemistry, that is chemical kinetics. This chemical kinetics is one of the important chapter for all common entrance examinations like CET, NEET, JEE, etc. Okay, so today we will start with this chemical kinetics. Before going to the MCQs, multiple choice questions, first we will see some theory part that we have learned in regular classes. Okay, so what does chemical kinetics means? Chemical kinetics, it is the branch of chemistry which deals with the rate of chemical reactions, the factors affecting the rate of reactions and mechanism of the reaction. That is known as chemical kinetics. Okay, so how slow the reaction is or how fast the reaction is and how the reaction will take place, all those things can be learnt or can be explained in this branch of chemistry. And there are two types of reactions that you can observe during any reaction. So first one is elementary reaction and another one is complex reaction. So elementary reaction means the reaction that occurs in a single step to give the product is called an elementary reactions. Okay, so it does not involve the number of steps. Only a single step reaction will be considered as elementary reaction. And another type is complex reactions. So the complex reactions, here the reactions that occur as a result of sequence of elementary reactions to give the product. Means it does not take place in only one step, but it takes place in number of steps. And number of elementary reactions combine to form complex reactions. So these are the two types of basic reactions that we can observe. Now, how to express the reaction, whether it is fast or slow, and that we known as rate of reaction. That can be given as rate of reaction. So what does this rate of reaction means? It is nothing but speed of reaction. Okay, so what it says, the rate at which the concentration of reactant or product participating in a chemical reaction alters is called rate of reaction. Means whether during a reaction, as you know, the concentration of reactant gets decreases and the concentration of product increases, and at which rate or at what velocity that process will take place can be explained by using the term rate of reaction. And the unit of rate of reaction is mole per liter per second or mole per liter per time. If they have given time in second, then we will write it as mole per liter per second. If they have mentioned the rate of reaction in terms of minutes, then we will call it as mole per liter per minute. Hour, if they have given in hour, mole per liter per hour. So in general we can say mole per liter per time. But in most of the cases the rate of reaction is given in terms of seconds. So the unit is expressed as mole per liter per second. Now consider the reaction A plus B gives the product C plus D. So here rate of disappearance of A, here A and B, these are the reactants and C and D are the products. As you know, as reaction proceeds, the A and B, these reactants concentration decreases and C and D concentration increases. So A and B go on disappearing and C and D go on appearing. So here rate of disappearance of A is given as A is equal to minus dA divided by dt. So where dA is small change in concentration of A and small interval of time t, that is dt. dt is small interval of time. At small interval of time, how much change in concentration of A will be observed. That is given by A is equal to minus dA divided by dt. And similarly, rate of disappearance of B is also given as B is equal to minus dB divided by dt, where dB is a small change in concentration of B and dt is small change in time. Now this will disappear, A and B. But what about C and D? C and D, since they are the products, so the concentration increases, hence they will appear more in amount. So therefore dC, where the rate of appearance of C is given as C is equal to plus dC divided by dt. Okay, and here dC indicates small change in concentration of C and dt is small interval of time, and rate of appearance of D is given as D is equal to plus dd divided by dt, where dd is small change in concentration of D and dt is small interval of time. So here minus sign indicates, see, in case of A and B we have indicated dA by dt and dB by dt by minus sign. This minus sign represents the decrease in concentrations of A and B, and plus sign indicates increase in concentration of C and D. So the overall rate is given as minus dA by rate is equal to minus dA by dt is equal to minus dB by dt is equal to plus dC by dt is equal to plus dd by dt. So the change in decrease in concentration of reactants, it is equal to increase in the concentration of products. So this is the overall rate which can be represented for the reaction A plus B gives C plus D. Okay. Next, rate law or rate equation. So it is the expression which relates the rate of reaction with which the concentration of the reactants. So rate law, it simply relates the rate of reaction with the concentration of the reactants. So that you have already learnt in regular theory classes only. The constant of proportionality K is known as rate constant. Okay. So average rate, it is the rate of reaction measured over a long interval. Average rate, where delta x is change in the concentration and delta t is large interval of time. So here this average rate is given as delta x divided by delta t. Okay, so this is how we will represent the average rate. Okay, then instantaneous rate. Instantaneous rate means the rate at instant particular moment of time or at that instant, because as you know, the reaction rate, it will always changes, it may increase or it may decrease during the reaction. And if we want to find the reaction rate at a particular time, then that type of rate is said to be instantaneous rate. So it is the rate of reaction when the average rate is taken over a particular moment of time. And instantaneous rate, it is given as dx, okay, divided by dt, because here the small changes will be taken at a small change in concentration upon small interval of time. That will indicates instantaneous rate. Here delta means it is a considerable change in concentration of reactant and considerable change in time. Okay, so that is average rate, and this dx by dt, it indicates instantaneous rate, where dx is small change in concentration and it is smallest interval of time. So it is the expression which relates the rate of reaction with concentration of the reactants. Then rate constant. When the concentration of reactants is unity, then the rate of reaction is known as rate constant. It is also called as specific reaction rate or specific reaction rate constant. The constant of proportionality K is known as a rate constant. Then molecularity of a reaction. The total number of atoms or ions or molecules of the reactants involved in the reaction is termed as its molecularity. It is always in whole number and is never more than 3. and it cannot be 0. So remember this molecularity of the reaction. It cannot be 0 and it is always a whole number, and what it represents, how many atoms or ions or molecules are involved in the reaction. Then order of a reaction. So order of a reaction is the sum of exponents power of the concentration of reactants in the rate law is termed as order of the reaction. It can be in fraction, it can be 0 also. So if rate law expression for reaction is rate is equal to K into AX into BY, where K is rate constant. This square bracket indicates concentration of A raised to X, concentration of B raised to Y. For this rate expression, the order of reaction can be calculated by sum of power of the concentration of reactants. That is, these are the powers X and Y. So order of reaction is equal to X plus Y. And remember, order cannot be determined with given balanced chemical equation. It can be experimentally determined. But molecularity of the reaction, it can be determined theoretically. Okay, but order cannot be determined theoretically, only it can be determined experimentally. Then integrated equations, that also you have studied. So here I have simply mentioned the equations, not the derivations. So first we will see integrated rate law for zero order reaction, where R gives the product P. R is reactant and P is product. For this, the integrated equation as from rate expression dx by dt is equal to K into R naught. Here concentration of R raised to 0. It indicates the order of the reaction is 0. Upon derivation, we will get K is equal to R naught minus R divided by T. So this is the integrated rate law for zero order reaction. And if we plot a graph between concentration of R versus time t, the graph is straight line with the slope equal to minus k and intercept is equal to R naught. So graph I will show you that in next slide. Okay, so simply remember here. Then half-life of a reaction. The time taken for a reaction when half of the starting material has reacted is called half-life of a reaction. So for zero order reaction, the half-life time is T half is equal to R naught minus R naught divided by 2K. So this indicates the half-life of a zero order reaction. It is dependent on initial concentration. Here R naught means initial concentration. So half-life of a zero order reaction is dependent on initial concentration of the reactants. Okay, then rate law for first order reaction or integrated equation. So it is given as K is equal to 2.303 divided by T log R naught divided by R, where R naught is initial concentration, R is concentration of the reactant, where K is rate constant and R naught is initial molar concentration, R is final molar concentration after time t. And this can also be given as K is equal to 2.303 divided by T log A divided by A minus X. So where A is initial concentration reacted in time t, final concentration after time t is A minus X. If we plot a graph between ln R with time, we get a straight line whose slope is equal to minus k and intercept as ln R naught. For first order reaction, the half-life time is T half is equal to 0.693 divided by K, where K is rate constant. This expression shows that the half-life of a first order reaction is independent of initial concentration, because this expression does not involve any concentration terms. It involves 0.693 and K. It is also a constant. So it is independent of initial concentration. Examples for first order reaction here given. Okay. Next, so here this is the graphical representation where we can observe the graph is plotted for rate versus concentration of the reactant. Okay, for zero order, for first order, for second order also. This is how the graph we obtain. And here also for zero order, half-life and concentration. Here we have they represented graphically for these three orders: zero, first and second order. Okay, so remember these graphical representations. Next, temperature coefficient. It is the ratio of rate constant of a reaction at two temperature differing by 10. So temperature selected are usually 298 Kelvin and 308 Kelvin. This temperature coefficient is given by RT plus 10 divided by RT is equal to 2 to 3. So always remember, whenever the temperature of a reaction increases by 10 degree, then the rate of reaction will increases 2 times or 3 times. So almost all time it doubles. Okay, so hence this temperature coefficient is equal to 2 to 3. Then Arrhenius equation is a mathematical expression to give a quantitative relationship between rate constant and temperature, and the expression is K is equal to A into E minus EA divided by RT. So one of the important expression, Arrhenius equation, where A is Arrhenius factor or frequency factor. It is also known as brief exponential factor. R is gas constant, EA is activation energy, T is temperature, K is rate constant. So if we further simplify this, we will get this equation also. Okay, so remember these equations, and this is the graph which is obtained when we plot log K versus 1 by T. The slope obtained will be minus EA divided by 2.303 R. Then, as you have studied the first order reaction, zero order reaction, second order reaction, there is another type of reaction where we call it as pseudo first order reactions. So what are these things? These are the reactions in which more than one species is involved in the rate determining step, but still the order of reaction is 1. So when you see the reactions, it appears to be second order, but still its order is 1 only. Hence it is said to be pseudo first order reaction. So for example, in case of acid hydrolysis of ester, if you observe this, there are two molecules are involved. You can say it is a second order reaction, but actually it is a first order reaction, because H3O plus means it is water is present in more amount. When water is taken in large excess, then the order of the reaction becomes first order. And here also in inversion of cane sugar, there also if we simply observe the chemical equation, we will say it is a second order reaction, but it is a first order reaction. Hence we say the order of reaction is experimentally determined. It cannot be determined theoretically, but molecularity can be determined theoretically. And another example is decomposition of benzene diazoxime halides. So these are some examples of pseudo first order reaction. Then activated complex or transition state. Activated complex is the highest energy unstable intermediate between reactants and products and gets decomposed immediately to give the products. In this state, bonds of reactant are not completely broken while the bonds of product are not completely formed. So you can simply represent that activated complex. Suppose A, B, C, three products are there. The breaking of bond between A and C, it is indicated by dotted line, and the formation of bond with another molecule, that is B, is also denoted as dotted line. This indicates there will be simultaneous breaking and formation of bond has been taking place. If you observe in SN1 reaction, there you will get a transition state that itself is known as activated complex, where there is a formation and breaking of bonds has been taking place simultaneously. Okay, then the threshold energy, it is the minimum amount of energy which the reactant must possess in order to convert into products is known as threshold energy. For any reactant to undergo reaction, we should supply some amount of energy, and that will undergo reaction and forms the product. That minimum amount of energy which is required by the reactant in order to form products is known as threshold energy. Then activation energy, the additional amount of energy required by the reactant so that their energy becomes equal to the threshold value is known as activation energy. And this activation energy is given by EA is equal to ET minus ER. ET means energy, threshold energy, minus energy of reactants. Lower the activation energy, faster is the reaction. Remember this. Okay. Then if I want to change or to alter the rate of reaction, how to alter that rate of reaction? That can be done by one type of chemical substance that is known as catalyst. So catalyst, it is a chemical substance which alters the rate of reaction without itself undergoing any permanent chemical change. In the chemical reactions, catalyst provides an alternate pathway or reaction mechanism by reducing the activation energy between reactants and products, and hence lowering the potential energy barrier as shown. Means it decreases the activation energy. Okay, by decreasing the activation energy, it will increases the reaction rate, and also it changes the path. When it changes the reaction path, then activation energy gets decreases, and hence the rate of reaction gets increases. This is the graphical representation where activated complex formed in presence of catalyst and activated complex formed in absence of a catalyst. If you observe here, without catalyst activation energy is high, but with the catalyst the activation energy is low. So that's why the rate of reaction increases. Then theory of reaction rates. One of the theory is collision theory. So what does this collision theory states? According to this theory, the reactant molecules are assumed to be hard spheres, and the reaction is postulated to occur when molecules collide with each other. So the reaction will take place when the molecules will collide with each other. The number of collisions between reacting molecules taking per second per unit volume of a reaction mixture is known as collision frequency, ZAB. So remember, one of the important term it is. Then but only those collisions in which the colliding species are associated with certain minimum amount of energy and collide in proper orientation result in the product formation. Such collisions are called fruitful collisions or effective collisions. So here the rate is equal to minus dV divided by dt, that is equal to collision frequency into fraction of effective collision. This can be represented like this, where ZAB represents the collision frequency of reactants A and B, and e raised to minus EA divided by RT represents the fraction of Na molecules with energies equal to or greater than EA. So they account for effective collisions. Another factor P called the probability factor or steric factor is introduced. So rate is equal to PZAB e raised to minus EA divided by RT. So this is all about chemical kinetics. Next, we will move to the questions based on chemical kinetics. The first question, the term minus dt by dt in a rate equation refers to the concentration of a reactant, the decrease in concentration of reactant with time, the velocity constant of reaction, none of these. So as you have already know, if I consider the reaction C gives D, how we will write the reaction rate? dC divided by dt. Okay, dC divided by dt is equal to what? dd, concentration of D, make it capital D, divided by dt. So here I will indicate dC by dt by minus sign and dd by dt by plus sign. So this shows the concentration of C is decreasing and concentration of D is increasing. So in this expression, minus dt by dt indicates the decrease in the concentration of reactant with the time. So option B is the right one, the decrease in concentration of reactant with time. So the second question, rate of which reaction increases with the temperature. So as the temperature increases, the rate of reaction will also increases, because as temperature increases, the kinetic energy of the molecules increases, and hence they will start to collide with each other more frequently, and hence the number of effective collisions will increases. As the number of effective collisions increases, the rate of reaction will also increases. Now this effect is observed for which kind of reactions? Will it be observed for any type of reactions, or only exothermic reactions, or endothermic reactions, or none of these? So whenever you consider any reaction, almost all the reactions with increase in temperature, the rate of those reactions will increases, because as I have said, as the temperature increases, the kinetic energy of the molecules will always increases, and hence they collide and they will undergo reaction. So the rate of reaction increases with the temperature of any type of reactions. So option A is the right one. And third one, the rate of a chemical reaction tells us about the reactants taking part in the reaction, the products formed in the reaction, how slow or fast the reaction is taking place, none of the above. So what does this rate of a chemical reaction tells? As you know, rate of a reaction, it is defined as the change in concentration of reactants or products at a given interval of time. Okay, so it does not explains about what reactants are taking place in the reaction, what products are formed in the reaction. It mainly concerns about at what velocity the reaction is taking place, means how slow or fast the reaction is taking place. That is only we will discuss in chemical kinetics. So here the answer for the third question is option C, that is how slow or the fast the reaction is taking place. That can be explained with the help of rate of a chemical reaction. Okay, so option C. Then fourth one, the rate of reaction increases as reaction proceeds, decreases as reaction proceeds, remains the same as reaction proceeds, may decrease or increase as reaction proceeds. So what happens to the reaction? If you observe option A, increases as reaction proceeds, will always the rate of reaction increases? No, sometimes the rate of reaction will also decreases. So option B, decreases as the reaction proceeds. It doesn't mean that the rate of reaction always decreases. Sometimes it increases or sometimes it decreases. And option C, remains the same as reaction proceeds. No, it will not remain the same. If it remains same, then it is said to be in equilibrium. Okay, so option C is also not possible. So A, B, C, these are wrong. Then option D, may decrease or increase as the reaction proceeds. Okay, this is the right one. It depends upon the nature of reactants and products and conditions which are maintained. So based on that, it may decrease or it may increase as reaction starts or proceeds. So option D is the correct one. Then fifth one, in the rate equation, when the concentration of reactants is unity, then rate is equal to. So what happens if I write here R, okay, R is equal to K, rate expression, K into A, okay. So this is the rate expression. If I say the concentration of A and B is unity, what will happen? Like this R. So R, that is reaction rate, is equal to what? K. So what is K? Because since here A and B are unity, I have not mentioned here. It is 1 and 1 only. 1 into 1, 1 only. And 1 into K, K. So rate of reaction becomes equal to K. Then what is this K? This K is known as rate constant or specific rate constant. And this is obtained when the reaction concentration of reactants is unity. Okay. So here in the given options, option A, if you observe here, option A, specific rate constant, is the answer. It is the rate equation when the concentration of reactants is unity. Sixth one, instantaneous rate of chemical reaction is, as I already told you, at a particular instant of time, what would be the rate of the reaction? That is known as instantaneous rate of a chemical reaction. If I say average rate of a chemical reaction at a definite change in concentration at definite intervals of time, if we measure the rate of reaction, then that is known as average rate. So here they asked for instantaneous rate of a chemical reaction. So option A, rate of reaction in the beginning, no. Rate of reaction at the end, rate of reaction at a given instant. So this is the right answer, option C. Option D, rate of reaction between two specific time intervals. This is the definition of average rate of a chemical reaction. So here option C, rate of reaction at a given instant, is known as instantaneous rate of a chemical reaction. Option C is the right one. Seventh one, the average rate and instantaneous rate of a reaction are equal at the start, at the end, in the middle, when two rates have time interval equal to 0. Because see here, average rate and instantaneous rate, that you already know. When they are equal at a particular moment, the values of average rate and instantaneous rate becomes equal. This is possible only if the two rates have time interval equal to 0. That is, when dt is equal to 0 and delta t is equal to 0, then the average rate and instantaneous rate values become equal to 0. That can be explained with the help of a graph. So refer the graph of average rate and instantaneous rate. There you come to know. So option D is the right one. 8th one. Which one of the following statements for the order of a reaction is incorrect? Order can be determined only experimentally. Yes, this statement is right one. Order is not influenced by stoichiometric coefficient of the reactants. This is also right. Order of reaction is sum of power of the concentration terms of reactants to express the rate of reaction. This statement is also correct. Option D. Order of a reaction is always whole number. So this option is wrong, because order of reaction, it may be whole number or it may be fractional. So option D is the right answer. This is the incorrect statement for the order of the reaction. So option D. 9th one. A reaction involving two different reactants can never be two different reactants. So if I say A and B, these are the two reactants, which gives C. So this is the reaction. This can never be bimolecular reaction. Yes, it can be bimolecular reaction because two molecules are involved. Second order reaction, yes, it may also possible, because if concentration of A and B both affect the rate of reaction, it would be second order reaction. It would be first order reaction also. Yes, it may depend on concentration of only one reactant, then it would be first order reaction. Unimolecular reaction. Unimolecular reaction means the reaction in which only one molecule is involved, but here the two types of molecules are involved, and hence this reaction can never be a unimolecular reaction. So option D is the right one. 10th. If the rate of a gaseous reaction is independent of pressure, the order of reaction is. So when the rate of gaseous reaction is independent of pressure, that simply shows the order of reaction is 0. It does not affect to the rate of reaction, hence the order will be taken as 0. Option A. 11th one. The unit of rate constant for a zero order reaction is, as I have already told you, the general equation for determining the unit of rate constant for nth order reaction, that can be given as mole raised to 1 minus n L raised to n minus 1 per second. So it is the unit of nth order reaction, a unit of rate constant for nth order reaction. But now we have to determine the unit of zero order reaction. So instead of writing n, write 0. What you will get? Mole raised to 1 L raised to minus 1 per second. I have simply substituted 0 in place of n. So 1 minus 0, 1. 0 minus 1, minus 1 per second. So mole per liter per second. Which option is right? Option A is the correct one. And 12th one. In the reaction 2A plus B gives A to B. If the concentration of A is doubled and that of B is halved, then the rate of reaction will be. So here first write the rate expression. In general, we don't know the order of reaction here. So simply by observing the expression, express it. If they mention order, you can write. Otherwise, you can take it as like this. R is equal to K into A raised to 2, B raised to 1. Okay. Now, here, if the concentration of A is doubled, they have given A is doubled, means K into A is doubled, that is 2. I will write 2 square. Okay, B is halved, 1 by 2, because it is half. Now what it becomes? K 2 square, that becomes 4, 1 divided by 2. Okay, now how much you will get? 2 ones are 2, 2s are. So what does R becomes equal to? 2K. So the rate of reaction will increases 2 times. So what is the answer? Option A. Option A, that shows the rate of reaction increases 2 times. So these are certain problems for this class. Next class we will solve some more questions on chemical kinetics.